Hello everyone. Today we're talking about Lesson 7.2 rates, and unit prices. In the first example, it focuses more on the first day of 7.2, where we found something unit rates, unit prices, what would be the better buy. The better buy is something cheaper per one of something. So in the first example, we're going to determine whether LaCroix purchased in a 6-pack for $3.95 or a 15-pack for $10.25 is the better buy. So I like to break it up into two parts. So the first one, and I like to say cash is king. I'll write that on the side. Cash is king. And that's just a way for me to remember that money goes on top of whatever the unit is. Okay, so I'm going to have $3.95. Make sure you label everything. I know myself and any of the other teachers will be very picky about that. So $3.95 for six LaCroix or a 6-pack. Now we're going to look at the 15-pack, and it is $10.25 for 15 LaCroix, the 15-pack. And we're going to round, like I said, we're going to round these off, but for right now, just in case we need multiple decimal places, we're going to, okay, so it's 0.683 repeating. So in the first one, it was 66 cents per LaCroix, or per can, you could say. And in the second one, it's going to be 68 cents per LaCroix, or per can. So I would say the better buy is your first one because it's cheaper per can. In the second one, Katie can buy a 15-ounce bottle of perfume for $32.19 or a 20-ounce jar for $40.16. Which is the better buy? So same strategy. We're going to have the $32.19 for 15 ounces. Make sure everything is labeled. And in the second one, sometimes I do the setup for both of them at the same time. That doesn't hurt anything. For the 20 ounce. So let's try the first one. We're going to do $32.19. All you have to do is divide the top by the bottom. Divided by the 15 ounces, and I got 2.146, which I'm going to clean up here in a minute. I'm going to look at the next one, and then I'm going to clean them both up. 40.16 divided by the 20 ounces, and that's going to be 2.008. So let me clean those up. Because we are talking about money, I prefer it to be to the hundredths place. So the first one is going to be $2.15 per ounce. And the second one is going to be $2.01 per ounce. So the better buy would be your 20-ounce. I said jar, but obviously bottle of perfume. Either of those would work. Now in the second portion of the problem, in the second problem, we're buying tickets for Trax Farm. There are tickets in several different price ranges. For each price range, there are adult and child rates. So a child obviously wouldn't cost as much as an adult ticket, where A we're denoting as an adult price and C the variable for the child price. It says write an equation that describes the relationship between the adult price and the child price. So when I look at this, I see 12 and 6, 9 and 4.5, 6 and 3, and we're looking for a relationship between the two. One of multiplication or division, something easier to work with. I'm going to divide the two. And obviously the first one's easy, 12 divided by 6. There's going to be a multiplier of 2. And we have to make sure all three of them have the same multiplier. That would make a proportional relationship. If they do, then we have this proportional relationship that we're interested in. And that's also 2. And then 6 divided by 3 is 2 as well. So there's a multiplier of 2. Every adult ticket is twice the cost of a child's ticket. And now it says to write an equation that describes this relationship. So what I'm going to do is I'm going to take my C was child, A was adult. Which costs more? So the adult one obviously costs more, so I'm going to have it on its own. The adult is twice the cost of the child. Another equation that would work would be the adult ticket divided by 2 is the cost of the child. Those mean the same thing, but there are two different equations that describe the relationship. Overall, you're seeing that the adult ticket is twice the cost of a child ticket. I absolutely love problems like example 3, and I'm sure your other teachers would say the same. They're very fun. You're given a graph that describes the situation that goes with everything. It's good to look at a graph and see what the labels are, what you're looking at. So the title of it says it's the cost of flavored water. On your y-axis, it's the total price of the purchase. And then on your x-axis is actually how many flavored waters were sold. And the question asks you write the unit price of a flavored water using the graph given. Give 2 reasons why the following graph represents a proportional relationship. Write the equation of the line given. So there's a lot going on here. So we're going to start with the graph because that's the information that's most important to us. That's the only piece that they've given us. The bottom says number of flavored waters sold. So if I look on the x-axis, as I go further to the right, I'm buying more. So of course it's going to become more expensive. What's most helpful to us are points that are on perfect dots, meaning on the crosshairs. Like this point's important to us, this point's important to us, the ones that we can read easily. If it's not right on a crosshair, right where you can, in intersection if you will, they're super hard to read and then kind of risky to use those points. So I like to use the points that are right at the crosshair. So that will be helpful to us. The unit price is cash is king, remember? So I'm going to write that on here again. Cash is king. Where we're going to have money in the numerator, and then the denominator is, in this case, a bottle of water. So in this problem, I'm going to use the first dot. It was $3, I got to label everything, per 2 waters. Which, when we divide that, because unit price, unit meaning 1, we need 1 of something. It's $3 divided by 2, which is $1.50 per 1 water. It's $1.50 per 1 water. And that's important. You're going to need to have all that labeled. The x-axis, that's easy. We just talked about it. All you have to do is write down number of flavored waters sold. Number. And I basically give you the answer, so it's super easy. Of flavored waters sold. And why? Well, that's also already labeled. That's the total price. Okay. Using x and y as our variables, we are going to write an equation. Your total should be on its own. So we're going to have y on its own. Y equals. And then what happened to x to create y? Well, that's where we use our unit price. It's $1.50, so $1.50, times how many bottles of water are sold to get our total price. Does that make sense? Yeah. So let's read it through again. Y is the total price. Does that equal $1.50 times how many waters we've purchased? The answer is yes. Now let's go back to our reasons up here. Why is the graph a proportional relationship? And we're going to really hammer this home, but there are some very simple things you can look at on a graph that would ensure that you're getting a proportional relationship. One is, does the graph go through the origin, through 0, 0? The answer here is yes, and that is step 1 to being a proportional relationship. So you would write the line, you could say the graph too, the line goes through 0, 0. You could also use the word the origin. The second reason, the line must be straight. And in 7th grade, we're going to be dealing mostly with straight lines, but it's super important that that line is straight. The line is straight. And those are super easy. Now, how could it not be proportional? Well, 1, if the line is not straight, and 2, if let's say the graph started in a different spot. If it doesn't start at the origin, it is not a proportional relationship.